Welcome to another episode of my podcast on the future of business and technology. In this episode, we are talking about space. And space isn't just about rockets and astronauts. It's this invisible backbone of our modern world, covering everything from navigation to communication. And to help us untangle this topic, I'm joined today by Thierry Klein, who is the president of Bell Labs Solutions Research at Nokia, to explore how the company is building the future of connectivity beyond Earth, from operating the first cellular network on the moon to shaping the foundations of a lunar economy. Thierry shares the tech challenges and opportunities driving the new space economy and how it will change life both above and here on Earth. Welcome, Thierry.
Thanks, Bernard. It's a pleasure to be here with you.
Yeah, it's good to see you again. Last time we met, I was at Nokia Bell Labs. I don't know, anyone who has followed me for the last few months has realized that I'm now working with Nokia on a project. I've become their futurist in residence. This is super exciting. And as part of this, we want to look at all their space technology. Many people don't realize, I guess, how much of our lives already depend on space infrastructure. It would be great if you could give us an overview of what's happening today and where
Mhm.
things are likely to go in the future.
Yeah, absolutely, Bernard. I think space has really enabled the development and the research and development and advancement of a number of technologies that we use today. If we just think about communication, actually, if you allow me, I go back 70 years. The first communication satellite enabled communication and TV broadcast between Europe and the US. And actually, we're quite proud that Bell Labs in 1962 launched with NASA Telstar 1, which was the first satellite, first communication satellite that then enabled Europe and US to be connected in real time and share data, video, and TV broadcast. So that's a really important milestone to bring people closer to each other and allow connectivity and communication and sharing of information in real time, even when you're not next to each other. Um, I think that's an important, really breakthrough of communication between people that are not physically in the same location. Um, and the same is true with a lot of space communication today when we talk about satellites for non-terrestrial networks that allow us to connect anybody on the planet, no matter where you are. If you don't have your terrestrial 5G connection on your mobile phone, but you have a satellite connection, you can still connect to the internet. You can still talk to anybody anywhere in the world, whether you're in a remote desert area, on a boat in the middle of the ocean, on the mountains, remote rural areas. Satellite and non-terrestrial networks allow you to connect really anybody anywhere. And I think the other part that came out of space exploration is GPS. The fact that we have GPS is really attributed to space launching satellites that allow us to have precise navigation, positioning, tracking, so that we can find our way. We know exactly where we are on Earth and how we go from point A to point B, and that's really enabled by this amazing constellation of satellites and GPS, GNSS, and other position navigation technologies. And that's really enabled. And that's just, I think, a couple of examples from a communication navigation perspective. Then there's so many advances that came out of space exploration, advances that were made because of the space program in the 60s, 70s, but also from the International Space Station when you think about science, medical advances, and so forth. So it's not just the communication technologies that were enabled by space exploration, but so many other industries that benefit from research and development in and science done in space.
Yeah, I've recently had a number of conversations with different astronauts on this show. And it was fascinating to see what is happening out there. So for me, this is absolutely mind blowing. From a massive solar farm that could produce energy on Earth, sending electricity back via microwaves that we were talking about, creating a manufacturing site almost in space, in orbit, where he could, in theory, 3D print human organs. It's like
Mhm.
mind-blowing stuff. Data centers in space. There's
Yep.
It's so exciting. So on a
Yeah.
personal level, then, what excites you about working on space projects?
Well, I think there's a few things. I was fascinated by space when I was a kid, and a key date for me was April 12th, 1981, which was the first space shuttle launch, and I was 11 at the time, and I just remember seeing that launch, and I could not believe that you could build something that massive, that heavy, that could take off, defy gravity, take off, go to space, land, and then you do it all over again. And that's where I was just incredibly amazed by that technology feats, and always knew I wanted to be an engineer. I knew I couldn't be an astronaut. I wouldn't be able to pass the training. So for me, developing technology that enables that and enables astronauts to do their incredibly dangerous missions that probably I couldn't do. I wouldn't have the courage to do those missions, but leveraging the technology that I'm working on and bring that to bear on these incredible feats that we do in space. So bridging that intersection between the space exploration, how amazing it is that we can do those things in the first place, and then bringing technology that I know to help with that space exploration and sort of that intersection. And if you think about the short amount of time that it took from the Wright brothers to us landing on the moon, it's just amazing how much technology advanced to enable those things in a very, very short period of time. And being in a position to contribute with the technology that I know and the technology that we work on at Nokia Bell Labs is just exciting to be part of that whole ecosystem of industries, not just the space industry.
Yeah, I couldn't agree more. How exciting. Um, Maybe you can share Nokia's overall vision then for the space economy and why it is such an important strategic focus now.
Yeah, I mean, certainly when we think about non-terrestrial networks that we talked about earlier, of providing connectivity anywhere in the world, we are a global networking infrastructure company. We built networks that connect everybody in the world, connect people, connect machines, connect devices. So it is really core to our business strategy and business objectives to develop technologies that connect the world. And as such, non-terrestrial networks are an integral part of that. So how can we take terrestrial technologies that we have, let's say wireless technologies like 5G, and put them in space, in low Earth orbit to start with, to provide connectivity anywhere in the world. So that's very, very core to Nokia's strategy, Nokia's business. But then when we look beyond and we look at deeper space exploration, we look at going back to the moon, it's pretty clear with the renewed interest to go to the moon and eventually go to Mars. And when we look at this picture of a lunar economy and human presence, sustained human presence on the moon, and the operational aspects of a lunar economy, the scientific exploration of moon and Mars, it's absolutely clear that none of that will happen without advanced communication capabilities. Um, we're used to seeing the pictures from the Apollo days, but they're very low resolution, black and white, grainy videos. None of that is acceptable in today's day and age. We need advanced communication to really have that situation awareness of what's happening on the moon, support astronauts, support robotic missions. So you need voice, video, data, real-time communication capabilities. We are a leading company that develops those technologies. So the natural question is, why would we not take the technologies that we know, that we develop, that we deploy every day to connect billions of people and devices? Why would we not take those same technologies and bring them forward to space exploration on the moon and beyond to support those that upcoming economy and presence of people on the moon. So it's an obvious and a natural fit from my perspective that we develop the technology. There's a need. We need to take those technologies forward and adapt them. A network on the moon is very different from a network on Earth. But at the core, we invested a lot in developing these capabilities. We should leverage the investments we've made.
Yeah, super exciting. And yeah, just the thought of having an actual base on the moon, operating, doing things, mining research that is fully connected is pretty mind-blowing. What industries beyond space agencies and telecoms could benefit from the space-based networks?
Yeah. Bernard, I think you touched a little bit on them in your earlier observation about manufacturing in space. I think there is a lot of exciting things that will happen with manufacturing, material science, semiconductor development, manufacturing in microgravity. The fact that you're in microgravity or no gravity means there's really no upside down, there's no left and right. And that has a lot of science opportunities for building different materials that may have different properties um, that take advantage of the fact that there is no microgravity or no gravity that pulls the molecules in your material together. And we might be able to develop completely new materials and use these materials in completely different ways, whether that's for semiconductor technologies or other areas. So there's exciting technology from that perspective that is still to be explored. And then when you get into the medical space, are there certain uh, uh, proteins and molecules and medicines that we can develop in space because we take advantage of the fact that there is no gravity. It's a pure, clean environment in vacuum of space. So I think those are very, very exciting areas. And then, of course, if you develop a lunar economy, there's going to be a lot of work that needs to be done and technologies to be developed from a transportation perspective, resource mining, drilling, and how do you agriculture, power, infrastructure? How do you develop all the things that we know every day on Earth? How do you develop those things for a fully operational city on the moon? So there's quite exciting things. I think a lot of people are excited about the potential presence of helium-3 on the moon as an energy source, which would completely be a game changer for us on Earth if we can harvest the helium-3 on the moon and also bring it back to Earth. And then the moon will be the launch platform, literally and figuratively, for going deeper into space, going to Mars. We'll learn so many technologies that we need when we go to Mars, and we'll be off Earth and outside of the Earth atmosphere as really a starting point to go deeper and harvest all the resources we need from a fuel perspective. For example, if you find water, ice, you can use that to extract and create fuel that you need to launch rockets to go deeper into space and into Mars. So I'm really excited about the moon and the potential that it holds. Of course, not everything is known, but that's the point of exploration, to discover things that we don't even know about right now.
Yeah, the fact that helium-3 could generate pretty much all the energy we need on Earth here is super mind-blowing. And I was just
Exactly.
recently, I met the founder of a company called Space Forge, who is actually currently having satellites up in space manufacturing semiconductors out there.
Mhm.
And that is just, for me, mind-blowing that we think there are satellites flying around our planet manufacturing things that we can then bring back to
Yep.
Earth.
Yep.
Um, Nokia, I mean, you touched on this, that Nokia operated the first cellular network on the moon. And you also said that there are challenges, it's not the same as here. So what are some of the biggest technical and logistical challenges in
Mhm.
making something like that happen?
Yeah, absolutely. We're very, very proud that we managed to design, build, deploy, operate the first cellular network on the moon earlier this year in early March 25 in partnership with Intuitive Machines and their Intuitive Machines IM2 mission. Um, and it was really taking the same cellular technology that are in your and my phone that connect devices and people and machines every day. So it is a standards-based, this was 4G technology. But then we had to reconceptualize what that network actually looks like. While it's based on cellular technologies, how do you build a network that withstands the mechanical stress of launch, transit to the moon, landing, from a shock, vibration, acceleration? Typical telecom network does not get launched on a rocket into space and have 7 Gs of stress on the equipment from a mechanical perspective. So a lot of work happened around that. Also, we needed to optimize size, weight, and power. Anytime you go into space, size, weight, and power are premium attributes. So how do we build the most compact network from volume and weight perspective? How do we reduce the power consumption as much as possible so we can support the requirements of the mission, we can support the capacity and coverage that we need to provide out of the cellular network, but we've reduced everything from a hardware and software perspective into the smallest, absolute smallest form factor. And then the other aspects from an environmental perspectives are around the temperature environment and radiation environment. So we had to do a lot of work to handle the heat dissipation because there is no atmosphere on the moon. So thermal management is a particular challenge. And then because again, there is no atmosphere, there is no, the equipment is subject to a lot of radiation in space. And while this mission was relatively short duration, it was planned for 2 weeks, we still had to harden the equipment against radiation. So a lot of engineering challenges that come back to the specific constraints from operating a network in space. The sending the bits and bytes over a wireless channel was actually the easy part because that's what we do every day, and none of that changed. But the whole environmental aspects, huge engineering challenges from that perspective. But we're proud that we overcame those, and as part of the mission, we managed to, as you know, Bernard, the mission had some challenges, and there was, you say, some off-nominal landing on the moon. In plain speak, that says the lander tipped over. But we did manage to operate the network for a short period of time while we had power. So we're proud to say that we've built technology that overcame all these engineering challenges that I described, and the network worked on the moon and was ready to take and make calls as envisioned.
Yeah, incredible. So how do you see this, how communications on the moon, this lunar communications, evolving from this initial network to maybe a fully functioning lunar economy?
Mm-hmm. If you think where we are right now, we still have individual missions that go to the lunar surface, maybe 1, 2, 3 a year. So it's still quite a few missions and not large numbers. So every mission might go to different regions. The mission we went on the South Pole. At the same time, there was another mission from a company called Firefly that went to the equatorial region on the moon. So very, very different parts of the moon and not close to each other at all. So every mission right now will bring their own communication capabilities and their own network to support the operation around the landing site where that mission goes. As we start going back to the moon more and more, having more frequent missions and going back to the same area or the same region, we'll start building up infrastructure capabilities on the moon. A lot of the missions in the future will go to the South Pole, and that's interesting from a scientific perspective because that's where we expect to find water, ice, and so forth. So as these missions go back to the same region, we should build up the infrastructure so that you don't have every mission bring their own network with the lander, but the infrastructure is permanently deployed. So when we get to a permanent presence of people on the moon, they also have their infrastructure with them. And you can think of when you go to, say you travel from the UK to Australia, you don't bring your network with you, you bring your phone. The network is there and you connect to a network. So we envision it quite similar, that initially you bring your network with you, you start standardizing on the technology. At some point, we deploy infrastructure, and the network will be part of a transportation infrastructure, power infrastructure, and a communication infrastructure. And any astronaut, any robot, any scientific experiment that goes to the moon will essentially get a device, maybe a data plan, and then will connect to the network that's deployed. So moving from individual mission to a program to infrastructure as a service on the lunar surface.
Yeah, that's pretty mind blowing. I mean, taking a device with you like a mobile phone and simply connecting connecting to the internet and connectivity on the moon. You
A 10, 15-year evolution. We're not going to be there in the next couple of years. That's
no.
really when you think about a 10, 15-year time frame when we have that established human presence and a functioning economy.
Yeah, maybe even looking beyond that, you mentioned that the moon could potentially be a launch pad to go further, to go to Mars and into deep space. Um, could you see Nokia connectivity playing part in that?
I can definitely see that. I think right now we're very focused on the moon, but there's no reason why the same technology that we deploy on the lunar surface could be deployed on the Martian surface. It might, in some ways, be easier to deploy it on the Martian surface than on the lunar surface. Um, but yeah, absolutely. As we start exploring Mars, as we have missions and probes going to Mars, and eventually people, the same challenge we have on the moon of connecting all the assets on the lunar surface, we have that same challenge on Mars. And again, we want to see what's going on and what is happening when we launch these missions to Mars. We, as the general public, mission planners, people responsible for astronaut safety, the scientific community. So yeah, absolutely, we need advanced communication capabilities on the Martian surface, as well as communication back from the moon back to Earth, and then from Mars back to Earth. And it will bring additional challenges, particularly from the delay between Mars and Earth. So how do we build large data rate pipes from Mars back to Earth, and how do we handle the up to 20-minute delay between Mars and Earth? And that will change. It'd be very difficult to have this kind of conversation if you're on Mars and I'm on Earth and there's a 20-minute delay in the communication. So we'll have to think about from a networking perspective, but also from an application and service perspective, and our mindset for communicating to astronauts on Mars will be very different.
Yeah, that with the 20-minute delay, this will make a very strenuous conversation. So what role do you see AI, sensing networks, and quantum communications playing in the future of space connectivity?
Yeah, that's a very broad question. There's a lot of things to unpack there. I think certainly AI will be important to help figure out how we deploy and operate and manage these networks, whether it's on the surface, in orbit, or really that long haul trunking line between Moon and Earth, or Mars and Earth, or Moon and Mars. So just how do we optimize and improve this network, because size, weight, power, and squeezing as much capability out of that network will be important. One of the area that Bell Labs is also doing research on that's quite exciting is looking at photonic quantum communication, and what is the maximum number of bits that you can send with one photon. And that is particularly exciting when you think really about deep space communication, where we have to look at other modalities than just RF, and optical and photonic communication will be one area to investigate further. So that's quite exciting. And then of course, we should not forget that a lot of the space exploration is also an area that a lot of countries and a lot of entities have interest. And so securing these networks will be becoming important. How do we make sure the communication is cryptographically secure? Because some of these networks transmit sensitive data, transmit geopolitically important data. So I think quantum cryptography and quantum secure networking will become an important aspect. It's not just about sending the information, but also sending it in a secure and protected way.
Yeah, it's pretty fascinating, all of this. And whenever it comes to quantum, I'm super excited by it. I will never say I understand it completely because it's a very complex field, but the thought of having quantum entanglement and this ability to leverage some of this for communication is pretty mind blowing.
Mhm.
Yeah. Um, can you share how AI will be used to manage and optimize these space networks in real time?
Yeah, I think it's really about handling the dynamic aspects of the network. Right now, the networks and the links are quite statically provisioned links, and the communication on these links is pretty much scheduled. But that's not how the internet on Earth works. It's a very dynamic network with dynamic routing, dynamic um, planning of how the information goes from one endpoint to the other. And you don't need to reserve time on the internet. You don't need to statically provision links if you want to um, send information, make a call, or access a web server. And I think that dynamic aspect will need to be brought to space exploration. You have the celestial bodies are moving, spacecraft are moving, and you should not have to decide weeks in advance that at that time you want to connect to a sensor and download information. So I think it will be a big change how dynamic and how real time the information will be flowing in the space network. And I believe AI will be a technology that helps us understand what is going on in the network and how we optimize the different links. There's traditional telecommunication networking technologies that will be brought to bear, but also AI will help us in real time optimize that network. But I think the bigger opportunity for AI is also on how we understand and how we process the data that we're collecting in space, because we'll be collecting a lot of information with the the industrial operations, astronauts, scientific experiments and probes. And the question is, do you want to send all that information back to Earth and process it on Earth? Or do you want to process it locally in space, whether it's on the spacecraft, on the lunar surface, on Mars? And it's really important, especially when you think about Mars with a 20-minute delay, and you can maybe send megabits per second of data back, but it's going to be very hard to send continuous gigabit per second data back from Mars. Yet we're collecting a lot of information on the moon, on Mars, on asteroids, and so forth. How do you locally process that information and send the relevant insights and the relevant knowledge back to Earth? You don't want to send information. Let's say you have an experiment on the moon that um, monitors temperature or monitors sandstorms on Mars. Do you need to send the information back to Earth just to say everything's fine all the time? Or do you only send the information back when there are anomalies, when there's really something that you need to act on? And all of that will call for edge computing and AI to process that data locally. So I think as we deploy these applications, connectivity is important, but that edge computing and that AI driven applications and AI driven insights and knowledge we extract from the data we collect will be important. I think will be absolutely important on the moon and vital on Mars, because we just won't have the capabilities to bring every single bit back. And it'd be wasteful to use that limited bandwidth to send information back just to tell us here that everything's fine.
Yeah, and all this super exciting stuff that you're talking about, all these innovations that you're working on for space communications, I can see that obviously all of this brings innovations back here to to Earth, right? And
Mhm.
you can apply and use those innovations here too.
Yeah, yeah, absolutely. I think we touched early on how does space exploration help us, and what are technologies we develop, and how do we use space application, space communication to benefit on Earth, like communication from satellites or Earth observation or manufacturing in space. But then in the process, we're also developing technologies that we can really use on Earth. And if I think about the communication um, area specifically, without touching on the other industries, we are building highly optimized, highly efficient, compact networks. As I mentioned, size, weight, power optimized networks. That is beneficial for a lot of industrial enterprise applications on Earth as well. If you think about operation in a remote mine or an oil rig offshore or remote wind farm, from a communication perspective, those environments don't look very different from the moon. If you think about a remote mine, you have trucks and machines operating, you have sensors, you have people. It's not very different from a mining operation on the moon. The moon just happens to be very far away and happens to be a harsher environment. Um, but I think the Bell Labs DNA is solve the hardest problems. And if I can build a network for those operations and I optimize it for that, I can definitely take that back to Earth and use it on Earth as well. If we solve the hardest problems, we can definitely bring that technology and size, weight, power optimized networks, autonomous networks that don't require any human intervention, can just be deployed in any environment and be self-healing, self-optimizing, self-configuring. Those aspects will be hugely beneficial for enterprise industrial deployments here as well.
Yeah, absolutely fascinating. If we fast forward to 2040, what would be your predictions for space and Nokia's role in it?
Okay, now you ask me to look into a crystal ball. Let's see. I think from a technology perspective, we maybe touched on a lot of things from a communication, AI, edge computing, quantum. But if I may have a prediction on how this all looks like from human perspective, I think over the next 10, 15 years, we'll continue to see launch costs come down with what different amazing companies in the space industry are doing from a launch vehicle perspective and spacecraft development. So launch cost will come down. That will lower the barrier for going into space. I think it will lower the barrier for economic activity happening in space. And we've already seen that over the last 10 years. And I think it will just accelerate with the new launch vehicles that are coming in the next few years. And I think what that will mean is, and maybe I'll have my prediction here, that by 2040, we will have, I say, daily flights to Earth orbit for manufacturing, research labs. People will commute to Earth orbit on a very, very frequent basis. Then I think we'll have maybe, so say daily to Earth orbit, weekly robotic missions to the lunar surface. We'll send machines, robots on a weekly basis to the moon to perform operations, resource mining, drilling, replacement parts, so forth. So maybe robotic missions on a weekly basis, human missions to the moon on say on a monthly basis. You'll take a ride on a monthly basis and you'll stay for several weeks, month on the lunar surface. So weekly robotic missions, monthly human missions to the moon, and then maybe if we dream a little bit, maybe annual missions to Mars. It's a little bit challenging because you have to get the right constellation between Mars and Earth, but maybe annual missions to Mars with we will definitely have people on Mars by 2040. I'm predicting that. I'll probably be wrong, but that's my prediction right now.
No, it's great. So, thank you so much for predicting. It's always difficult to put yourselves out there and say this is what I think is going to happen. But I think everything you said is 100% plausible, and
I'll come back in 2040, and if you
exactly.
want to have me, we'll check on the predictions in 2040.
Exactly. If we don't get there by 2040, at some point we'll definitely get there. Thank you so much, Thierry. That was super fascinating. It's just amazing all the things Nokia is doing around space communications. Thank you for sharing this with us. Super interesting episode. For anyone who ever wants to rewatch this episode, simply head to my YouTube channel where you can find this episode and hundreds of others. And you can also find them on any podcast platform. So thank you and see you soon.
Thank you.